welcome to a question on group 7. Now for this question we've got a 5 marker and we have a lot of information. We're trying to work out the reactivity in the halogens. So just so we make sure we know what we're talking about, we're trying to work out the trend in reactivity of the halogens of the group 7s. So we have the bullet points on the left hand side there of what solutions we have. We don't have any chlorine gas or chlorine water, and we want to carry out the minimum number of test tube experiments to determine what the actual order is. And we've also got some cyclohexane as well. So it wants us to say what we're going to add together to get the reactivity of the halogens, minimum number of test tube experiments, colours we're going to see, and then an ionic equation for one of the reactions that takes place. Okay, so now this is asking, this might seem like a bit of a difficult question, but we already know what the reactivity of the halogens is. We know that fluorine's the most reactive and it decreases down the groups. We already know that. So this is where that kind of helps us a little bit within this. And this question is going off the fact that you actually already know what the reactivity of the halogens is, and you just need to then go and prove it by using the equipment that you've got here, the solutions that you've got. Now, in terms of mixing the solutions, there's 2 that we can do. It wants the minimum number. Now, the minimum number is 2 if you pick the right 2. So, to start with, if we take barium chloride and we add bromine to it, so you write that out in words, or you can write it out as an equation there, BaCl2 plus Br2. Now, we know, if you've got your periodic table there, it goes fluorine, chlorine, bromine, and iodine. So we don't have any chlorine, water, anything like that. So we've got barium chloride and then bromine. Now these are displacement reactions. So the question is bromine reactive enough to come in and displace the chlorine in barium chloride? Well, the answer to that is no, it won't. So for that reaction there, the observation will be no reaction. Nothing will go on there. So what that tells us is that chlorine is more reactive than bromine. So that's one bit of the order done already. Now the next one we could do is if we take calcium iodide and bromine. Now again, the question is bromine reactive enough to come and displace iodine? Well, the answer to that is yes, there will be, and there will be a displacement reaction that occurs. So from these 2 experiments, from these 2 test tube experiments, we've determined that chlorine is more reactive than bromine, and that bromine is more reactive than iodine. So there we have our order straight away from just having 2 experiments done. Now for the second one, we could have a slight alternative, which is magnesium bromide and iodine. So let's say we didn't do the calcium iodide and bromine one, we can then do magnesium bromide plus iodine. And again, the question is, can iodine displace bromine in its compound? Well, the answer to that is no, there'll be no reaction there. So that tells us that the first one, that chlorine is more reactive than bromine, and bromine is more reactive than iodine, so we still get to the same endpoint as it is. So only 2 experiments need to be done to determine the order reactivity. So you'll get a mark for each of those. Now you then need to talk about your colours in cyclohexane for the reactions that you've done. Now again, if you know this, then ideal. If not, then this is where you're going to start losing some marks. So we've already picked up 2 marks, we've got to try and get the other 3. So for our first one, if we have barium chloride and bromine, we're getting an orange-yellow colour, so we mark for that. And for our calcium iodide and bromine, that will be, again, you get a bunch of different possibilities here, but essentially it's purple. Second mark there for that one. And then finally, we need an ionic equation. Now the one equation that does actually complete the ones that we have here is going to be the bromine plus iodine, giving us iodine plus Br2 minus. That is an ionic equation for one of our particular reactions. Now this is the sort of, not so much the bare bones, this is exactly what you need, but once you've written down those equations, you would then need to add on a line that says, so therefore this would be no reactions, therefore chlorine is more reactive than bromine. And the next one, we have calcium iodide and bromine. Bromine displaces the iodine, so therefore bromine is more reactive than iodine. Just have it tagging on a sentence after that just to make sure you're saying exactly what's going on there. And then after that, you're going to simply state, as I've done there, what the colours are going to be and what the ionic equation is going to be as well. So 5 marks there. It seems like you've got a lot of information there. Seems like quite a scary question potentially, but when you know it's talking about the halogens and you actually already know the reactivity of them, and displacement reactions you have seen before back at GCSE, it's not actually too difficult. The bit that's going to be bringing new things in are the colours in cyclohexane. That's something new to A level that you won't have seen before until you got to it, so that would be the new bit there. But in terms of mixing the solutions, you'll be able to use your GCSE knowledge essentially and be able to come up with those tests there. And then ionic equations, again, you've seen ionic equations before, so hopefully that will be okay for you there as well. Okay, so that will do us for today on questions with Group 7. See you next time.